Hello friends, myself Shriram Korde. We have seen quite a good amount of things now about arrays. So let's proceed forward. Now comes a very interesting thing which I have told you as part of earlier videos, that is array locations are contiguous or essentially they are consecutive in nature. So how do I basically prove that? Or how do we know that it's really contiguous or it's basically successive locations it's going to occupy? So let's get going and understand more about it. So here you can see I have this roll number array and I have just initialized it to some number, say 100, 110 like that. Okay, so and it's essentially 5 numbers are provided, and for the time being let's assume these are the student roll numbers. Okay, now the important point here is I want to see whether this roll number 0, then roll number 1 like that. So instead of roll number, probably some people will just call it as ARR. Okay, so like ARR of 0 and then ARR of 1, that means ARR of 1 is next to ARR of 0, then ARR of 2 is next to ARR of 1 like that. Okay, so how do I basically verify that? So to do that, we will basically need to print the address it occupies in the memory. So if I can print it, or if I can see that rather, then that's my job is done. So to do that, I can simply use a for loop, and what I can do is I can have this loop, a very simple loop which we already have written earlier, so we can just make use of it. And here you see what I am doing. It's a simple loop. I am going to print address of each and every ith element of the array, and here I am using percentage x. The reason to use percentage x is because it's going to print address in an hexadecimal number, and we can verify that also in the watch, that facility which is provided as part of Visual Studio Code debugger. Okay, so we will see that. So let me just here use another thing. Here I will just put percentage d and percentage d, and then here we will have ARR of I also. That means it's a value. So what we are printing now is address and value together, so that you understand what we are trying to do. Okay, so let's first print it. So let me just run this file. Yeah, you can see this, some address is there. Okay, so we don't need to worry what address it is. Okay, some b6 f9 dc and the value is 100. You can see this, then another address and value is 110 like that. Okay, and though I have used t, so that's why it is basically showing it closely like this. So here you can see then 150, then 200, and then 250. So that's the way typically you get address and the value, address and value. Okay, so we can always make it little nicer. So we can give t here. Okay, so that it looks neat. Yeah, so now it looks neat. So this is the address, this is the value, this is the address, this is the value. Now you see the address is 4FFAF4, and then after that it's an integer, that means it's going to occupy 4 bytes. So here it is 8. That is very important. Then obviously FC. Okay, then the whatever 00, and then obviously it is increasing by 4, and then finally the 250. Okay, so that's the way typically you see this. Now the question is, do I really need to use this percentage x and then print it? Need not be. We can use the watch also, the facility there. So let me just put breakpoints here, and I can have a breakpoint, and let me just do debugging. So let me close all this, and I can just do debugging of the file. Okay, now I can put the watch here. So how do I put watch? So here our variable name is ARR. So you can see this, basically here it has started with some 009CFCAC. Okay, and then these things are provided. Okay, now here the question can be, how do I print like this also, or how do I see this? So ARR of 0. Okay, then I can have say ampersand ARR of 1, like that you can have 2, 3, everything. Okay. So let's say we will take, so you see in the bracket the values are shown 100, 110 and all that. Now I want to see it matches to the print. Okay. So obviously I need to complete this loop which has halted it by putting the breakpoint. So let me just come out of this. So I will just step out and then you can see this 9CFCAC. Oh, forget the 00. So that is anyway not useful. So the 0x00 and then 9CFCAC. So here you can see this. That is the start address, and here you can very easily see this. Okay. So 9CFCAC, then B0. So that obviously it has increased by 4 bytes. Then here you see B0. This is the same thing which printed. Like that you can basically verify it. So that basically proves, now this proves that all my array elements are in the contiguous memory location. So what we learned from this is array elements are in consecutive memory location or contiguous memory locations. So that is what we learned by doing this. Okay. Now we need to also see about the bounds checking. Okay. So the first learning is array elements are in contiguous memory location, and that's why we can use this subscripted variable that is 0, 1, 2, 3, and we can access it. Okay. So that's the way, and that's why this particular thing works. So this is a very important learning from this thing which we just did in this file, that is array. Okay. Now comes the another important thing is, let me just create a file and let me just say array6 dot c. Okay, and let me just copy this, or we can simply copy whatever we have done earlier. Probably we have done something here. Okay, we were entering the marks. Yeah, this is good enough. So we can simply copy this and we can paste it here. Okay. So now what I have done is, this is a roll number. Obviously this is not reading and writing. Here it is about bounds checking. Now does it mean that it's really going to crash the code and all that? It need not be. Okay. So let's see this now. So we have this array of size say 5. Okay, and I will make it here 5. And I will basically remove this. Okay, we don't require this. We don't require this. Now what I am doing, that is very important. I am just putting here 50. Okay, what is important here is, we have an array of size 5. This is very important. So here the size of array is 5. Okay, and now I am basically writing a for loop which starts with 0 and goes till 49. Okay, that means now I am going beyond basically what I have allocated, or what I have reserved for, rather. Let me use the word reserved rather than allocated. Okay, so the reserved, I have just reserved 5. So it is the same situation. The way in which the example that was given is like in a train or in a any other say bus travel, you basically reserved only in train, you reserved only say 5 seats, and now you basically went along with your friends, and you are a group of say 10 people or 15 people. Then obviously the train person or the authority who checks the ticket is going to throw out, or is going to say no to the remaining extra people. Only 5 people are allowed. Okay, who have valid tickets. Okay, so on the similar lines here, now we are going to check the bounds checking. Okay, so let's say this, what happens. Obviously here we will have to see how the things work. So here let me just close this file. We close all these files. Okay, and now I'll just run this file. So once again let me run. Nothing happens. You see what has happened, because I am trying to do something which is beyond. So that means my program essentially has crashed. Okay, so program has crashed. If I just increase it, or if I try to print the values, suppose if I write another loop here, okay, and if I now try to print this, so instead of this I can have say printf and then percentage d, and now let's try to basically run this code. See what has happened. You never know what exactly has happened because we only gave up to 5 and it just went on. We never know that when it will work, when it will not work. Okay, so if I just increase it to say 1000 or maybe more, and I will just put the same thing here, and let's run this now. Now you can see it has crashed. So the behavior is very unpredictable. Why? Because I never know when my situation will land up in trouble. Why? Because I only have reserved 5 locations. Okay, and now I am writing such a big number loop. Now I never know which portion beyond 5 is part of system. Okay, now that's a little complicated, so I don't want to make it complicated. That means now we don't have a control over it, and that's the important point with respect to when you write a use an array and when you write a loop, then you essentially need to worry about bounds. So bounds are 5, and that's the correct way to do that. Now you may say, sir, it has worked for 50. Yes, it may work, it may not work, but however, earlier the program didn't work and it didn't give anything. Okay, so it is a very unpredictable behavior because that the situation or that underlying control lies with the operating system or essentially the system which we don't have any control. So that's why we should be worried about bounds and we should ensure that we use correct bounds. So that's the important learning with respect to this activity. Now comes the another example or another important point is about say how do I pass array elements to another program. Okay, so let's see that if I want to do it, then let me just copy the same code. I'll just copy this code and let me just paste it here. Okay, now let us say that this is the roll number and I am initializing it to say this is a 10 size. I am purposefully increasing it here. Let's say I'll do it 10, and now I don't want to print this roll number in the main. Okay, and I want this particular thing to be printed in a function called as say myPrint. And now here I am going to pass the integer. That means now here I need to do the declaration. So how do I do that? So here it doesn't have any return type. Then the name of the function is myPrint and it's going to take an integer value. Okay. So what now we can do is we have initialized this thing to here, and now we need to basically print this particular thing in this function. So let us say that I will use x, and then here I will have printf, and then in the printf we can basically use percentage d, say slash t, and then comma x. Now I need to call this function. So how do I call? So obviously I will call this function from main, and then here I need to pass the each and every element. Why? Because now I still do not know how do I make my array completely available to a function. So that is the next thing, and that's why we need to learn that. But before that, how do I pass each and every element? So for that I obviously will use this loop. So I'll use this loop. In the loop I'm going to call this myPrint function, and in to this function I'm going to pass each and every element. So how do I do that? So I will use this roll number of I. So that means here I have first initialized this array to some value, say roll number starts from 1000, and then I essentially call this function myPrint from main, and essentially it will be called 10 times. So let's see this first. Yeah, so you can see this 1000, 1001 and all that is getting printed using this function which is myPrint. So now this basically leads to a important point. The point is that if I have to call this function multiple times, suppose if this would have been 500, then 500 times this function will get called. If it is 1000, then 1000 times the function will get called. I don't want to do that. So what should I now do is essentially I will just pass the array once only, and then why don't this function take care of further things of printing the each and every value. And that is what we will learn in our coming videos, where we will understand arrays along with pointers, and we will make use of that, and then we will be able to print this particular array in one go, rather than, that means we will be able to send this array in one go rather than sending each and every element in a loop. Okay, so here you will see it is called n number of times, it's called n times, depends on that. N is essentially the what is the size here, and which we don't want. It should just call, this function should be called only once, and then this function, whatever my print function, should take care of this. So that will be what we will learn in our further videos. I hope you like this video. Thank you.